Derivatives is a really simple thing that can seem as something difficult, but it's actually really simple, as it's just take a number and lowering its grade. As you can see here, there are some examples of the kind of situations that you can find when derivating a function. x3 will pass to be x2, x2 to 2 times x to 1, and any number to 0. Any number it's alone, meaning that it doesn't have an x. This, it's really simple to understand. As I said, it's take down a grade to the number. As you can see here, the 3, it's now a 2, which is 1 less. The 2 here, it's becoming, it is not anymore an exponent but a number, and the x is alone. The x here, when it's only alone, that doesn't have any exponents, it is becoming a 1, and when there is a number without an x or an unknown value, it will be 0. As it is becoming less, its grade is being lower. An important fact that also you need to remember is the symbol that it's used when you derivate a function. Here you can see that is f of x in this example. Remember, it can be f of g, f of h, depending on the problem that you're solving. But the important thing here is this, as this shows that you're talking about a derivative. Now that we understand and see a little bit of the general view, we can start doing our two problems of derivatives. In the first case, we see that there is f of x equals 3x cubed minus 2x squared minus 6. This is very simple, and as already we have these key items, we can do easily and fast. This will be f of x. Remember this for being a derivative. So 3, this 3 right here, it is going to be lower, or put like as a normal number. So it will be 3 times 3, and this x3, as I told you before, it's gonna become a x2. So we will have x2 right here. Then continuing our function will be minus 2. Remember, this is not becoming a 0 because you have an x right next to it. This x2, as I told you before, is becoming a 2 times x, so 2 times x. And finally, we have minus 6. As it is a normal number with any unknown values next to it, it will become a 0, so minus 0. Three times 3, it's 9, so 9x2 minus 2 times 2, which is 4x. And here the 0, as it is a 0, we cannot write it and leave our derivative like this. For our second problem, it can be seen a little bit more difficult because of the fraction that we have right here, but it's actually not. And you're gonna see it because as we're writing it, the first thing we can start doing is this 3 of being an exponent, passing it to a normal number. So it will be 3. And now we need to have an times the fraction, but as we take this 3, it will be x2, but that x2 will be next to it. And now we will have the 3 that it was on the fraction right here. But you're wondering, now that we have take the x and that we have take the 3, what is gonna be left? Well, as there is nothing, and it will be just like the number, we can put 1, and that one make this have sense, and you can see it because this 3 right here has passed here, this x3 has passed to x2, and as there was nothing left, that x, it was being alone. And remember, in the key we said that x, when it's alone, it is 1, so we have 1. Continuing our problem, the next thing is minus 3. Remember, as there is not alone, so we maintain in the 3 times 2x, and that's why we have x and 2. We take this number to a big number here, and the x is being alone, plus 5. But here this x doesn't have an exponent, and remember, when there is no exponent with the x, it is passed to a 1, and this minus 2, as the 2 is alone and doesn't have any unknown values, it will be 0. So it will be f of x, it's equal to, when we multiply 3 times 1/3, it will give us a result of 1. But when we have this x2 will maintain. As it is just 1, we can select or choose not to write it, so I will not write it. So x2 just, then 3 times 2 is 6, so minus 6. Remember always to maintain these symbols like the plus or the minus. They're really important to maintain. So 6. And we can see now that as we just did that, it will be 6x. Now we can see that 5 times 1 is 5, so it doesn't change. Minus 0 still is 5, so we put plus 5. And that will be our derivative.